Are there alternative cathode materials that exhibit similar reversible phase transitions while offering improved electrochemical performance? What lessons can be learned from lithium-ion battery cathodes regarding phase transition mechanisms and structural stability? How do computational modeling and experimental studies contribute to understanding the phase transition behavior of NiCu2? What emerging research strategies focus on optimizing the phase transition properties of NiCu2 for practical sodium-ion battery applications? How do the charge and discharge curves of NiCu2 illustrate its electrochemical behavior and performance as a cathode material? What specific features in the charge-discharge profiles indicate the stability or instability of NiCu2 during cycling? How does the voltage evolution during charge and discharge cycles reveal the underlying phase transitions in NiCu2? What mechanisms contribute to capacity attenuation observed in NiCu2 over multiple cycles? Can Davis Syrinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the initial specific capacity compare to the capacity retained after several cycles? And what factors drive this decline? Why does capacity fade become more pronounced with an increasing number of cycles? And what structural or chemical changes are responsible? How do the charge-discharge curves illustrate the relationship between sodium-ion intercalation and deintercalation processes? What role do voltage plateaus play in understanding the phase transitions occurring within NiCu2? How does the presence of multiple voltage platforms indicate severe phase transitions? And why is this detrimental to cycling performance? What are the specific phase transition mechanisms occurring in NiCu2 during charge and discharge cycles? How do these transitions affect sodium-ion diffusion and overall battery efficiency? What structural characteristics of NiCu2 contribute to the observed voltage platforms? How does the evolution of the crystal structure during cycling impact its stability and specific capacity retention? In what ways does the interaction between sodium ions and cobalt oxide layers influence the electrochemical behavior of NiCu2? Are there external factors such as temperature, pressure, or electrolyte composition that accelerate phase transitions and further degrade cycle life? What strategies have been proposed to mitigate the negative impact of phase transitions in NiCu2? Could material modifications or doping approaches improve its cycling stability while maintaining favorable electrochemical properties? How does NiCu2 compare to other sodium-ion cathode materials in terms of phase transition severity and capacity retention? Are there alternative synthesis techniques that could enhance the structural integrity of NiCu2 and reduce phase-related degradation? What?